Welcome back to the Algebra 2 series, and today we're continuing with the third of three videos on the parabola. And today we have an example where the vertex of our parabola is given here. It is shown as a vertical parabola, and an additional point, 0, 2, is given. It states here, after writing the equation, find the focus and the directrix. And of course, the trick to this problem is that it appears that perhaps this segment straight across could be the latus rectum, but in truth it's not. And so what we have to do is calculate how this 0, 2 helps us find the actual focus. First of all, we see that this graph is in the form x minus h squared is equal to 4a y minus k. So really, this entire problem revolves around finding the a value in the parabola. Let's first replace the h and k with our vertex values 3 and 1. So we're going to rewrite this as x minus 3 squared is equal to 4a times y minus 1. Simply replacing my h and k with those vertex values. Now to solve for a, we're simply going to borrow these values for x and for y. So we'll put those in the equation itself. So let me just start this the right way here. 0 minus 3 squared is equal to 4a. 2 minus 1. Or, continuing with the calculation, this becomes 9 is equal to, now 2 minus 1 is just 1, so that becomes 4a. So as we solve this out, we see 9/4 is the a value. Well, that will be substituted all the way back in this part to write the equation. So let me finish this out. The equation of this parabola is going to be x minus 3 squared is equal to, now the number 9/4 here is a. And so when that goes in there, it goes only in for the a, and it will cancel with this 4 here. So the answer becomes just a 9, not 9/4. Yeah? Y minus 1. Okay, so this is our equation. And keeping in mind that since a is 9/4, that means we need to go up 9/4, which is 2 1/4, to get to our focus. And then the endpoints of the latus rectum must be out here. So it asks us to find the focus, and then we're going to have to go backwards 9/4 to find our directrix down here. So first of all, moving up 9/4 from 1, where 1 is equal to 4/4, so 9/4 plus 4/4, or 13/4 is the height. That would put our focus at the point 3, 13/4. That's the value of the focus. And of course, if we go down 9/4, this will be, of course, 1 is 4/4, and we're going to go down 9/4. So this point would be at 3, -5/4, and that would give us a directrix equation as y equals -5/4. So there you have the directrix given there, you've got the focus here, and you have the equation above. I've made a total mess of the page here, but that's all right. At least we got the answer settled in. Let's try one more of these. And the last one that I have, and let's see if our computer here will do the job. There we go. Write an equation for a horizontal parabola with focus 3, 7, containing the point -5 and -8. Let's draw a picture of this and see what we're looking at here. We've got 3, 7, which is somewhere around here, and -5, -8, which is way down here somewhere. And of course, negative 5, negative 8 is a point on the parabola, and 3, 7 is the focus. So I'll put an F there for focus. So there are two ways that this could go. This could go either to the left or to the right. So if it opened to the left, then our vertex would be somewhere in this location, and it would come this way. This is a fairly large parabola. Or it could open to the right, and then the focus would be here, and the vertex would have to be way over here somewhere, and the graph would have to do something like this. So that's our two, those are our two possibilities for the vertex being on the left or the right there. And let's see now, how could we figure this out? Let's try to work the one in red there and see if we can figure that one out, where that's the spot. So the vertex is right over here. We know this is HK. And of course, that also means that the directrix is going to be on the opposite side of that. Okay. And of course, I guess the key to this problem would be to find one of these items. Well, here's how we take a look at this one here. If we're looking at this distance here, by the definition of the parabola, that distance has to be equal to this distance here. So let's call that distance 1, and we'll call this one distance 2. We know that d1 is supposed to equal d2. But we can find the distance between any 2 points on the Cartesian plane, so I'll just do that by the distance formula. d1 is equal to the square root of 3 minus negative 5 squared, and then 7 minus negative 8 squared, or in this case, 8 squared plus 15 squared. And I'm starting to sense something here. Notice this is 8 and 15, and I remember that there is a Pythagorean triple that's an 8, 15, 17 right triangle. So certainly when we're finished with this, D1 is going to come out to be 17. Well, that's kind of sweet because that tells us that 17 is a whole number, and we can also then come 17 units to the right of that 5, negative 5, negative 8. And that will put us at 12. So this would be x equals positive 12. So that gives us a whole lot of information now. And erase this spot over here. What it tells us is that since this is 12, and this is 3 comma 7, then I should be able to go out to 12. So that's going to be 9 units right there. So I've got 12, and then I see then that's going to be 9. So I should be able to identify my vertex, which is right here in between, or 4.5 units to the right. So that would be 7.5 comma 7, or 15 halves comma 7. That's my vertex. And then we should be able to cut that. The a value here should be 9 halves, or 4.5. Okay, this is a lot of information, but let me write this all out. A couple things that happen from here. We know that let me bring this down just a bit. We know that the form of our parabola is y minus k squared is equal to negative 4a x minus h. This is a left-facing or left-opening parabola. We also have identified the h and the k, or the vertex, and we've done that right here, 7.5 comma 7. So that would be y minus 7 squared, and then this will replace the 4a with our correct value, and this is going to be x minus 15 halves. Now, we also see that 9 halves is a, negative 4a. If we multiply that out, we get negative 4 times 9 halves. And we'll cancel here and make 2, that's negative 18. So negative 18 is the value that comes in here. So we have written one of the two equations for a horizontal parabola given a focus, here at 3, 7, and given a single point, we should be able to write that equation. So there you go. That's one of them. And the other one would be the same way, except going in the opposite direction. So you would have to go from -5, -8. You'd have to go to the left 17 units in order to find that directrix. So you can find each directrix by going left or right 17 units. Very tricky little problem. That one, of course, will need a little bit more practice at when you're given a focus and a point. I hope that helps you out in this parabola section. Good luck with your examples. Have a great day.